Hello, I'm Engineer Mikko de Torres from the Department of Electronics Engineering at Batangas State University. I'm thrilled to welcome you to the MexE 406 Robotics 1 course. Throughout this course, we will delve into both the fundamental, theoretical concepts and practical applications of industrial robots. As part of this course, you'll gain comprehensive insights into the intricate world of robotics. While primarily designed for third-year mechatronics engineering students, this course holds immense value for those pursuing computer sciences and various other engineering disciplines. Let's embark on this enlightening journey together. Our course has a clear roadmap in mind. These objectives will guide us as we explore the fascinating realm of robotics. First is the introduction. We will begin by understanding the foundational concepts. I'll walk you through the definitions of robots, mechatronics, and robotics. We'll address some common misconceptions that often cloud the understanding of robotics. Clearing up these misunderstandings will pave the way for a more accurate comprehension. As we progress, we'll touch on advanced concepts that broaden our perspective on robotics, ensuring you're well equipped to tackle complex topics. Second is the mechanical manipulator. I'll introduce you to the concept of a mechanical manipulator and its significance in the field of robotics. Next, we will delve into the anatomy of mechanical manipulator, breaking down its components and functionalities. I'll explain the vital roles that links and joints plays in the mechanical manipulator's movement and flexibility. Third are the types of mechanical manipulator. We'll explore various types of mechanical manipulators, highlighting their unique characteristics and applications. This will help you understand the diversity in robotics design. Fourth is the mechanics and degrees of freedom. I'll introduce the concept of degrees of freedom, a crucial element in understanding the range of movements a robotic system can achieve. This is a fundamental concept that underpins many robotics applications. Fifth is the kinematic diagram. We will create it as a visual representation that illustrates the connections between the components of a robotic system. This diagram will help us analyze the system's motion more effectively. Sixth is the Denavit-Hartenberg notation. This is a powerful tool that simplifies the mathematical representation of robot kinematics. I'll guide you through this notation, making complex calculations more manageable. Seventh is the robot kinematics. We'll dive into the realm of robot kinematics. You will gain insights into how robots move and the mathematics that govern their motion. Finally, we'll explore the exciting intersection of design and programming. I'll show you how coding plays a pivotal role in bringing robotic systems to life, bridging theory and practice. These are the building blocks that ensure you're ready to dive into the robotics adventure. The prerequisite courses, which are engineering mechanics and advanced math for mechatronics engineering. So, engineering mechanics is to equip you with the basic principles of how things move and interact. This knowledge forms the foundation for understanding the mechanics of robotics system. While for the advanced math, we will delve into some advanced concept and of mechanics of grasp of mathematics specific to mechatronics engineering. Don't worry, we're not going to calculate rocket trajectories, but a good math foundation will make our discussion much smoother. Our programming language is basic Python. If you got a basic grasp of Python, you're all set. We'll be using the versatile language to make our robots come alive. If you're not quite there yet, no worries. There are plenty of resources to help you get started. These are the courses, or this is the course that complement our robotics journey, providing you with a more holistic understanding. As robots often involve sensors, actuators, and electronic components, having a grasp of electronics measurement and instrumentation will enrich your understanding. Before we go further, let's pause and acknowledge the math courses that have brought us here, which is arithmetic, logic, algebra, trigonometry, analytic geometry, solid mensuration, and linear systems and algebra. These courses form the foundation and are more connected to our robotics journey. Let us direct our attention to the automation courses that have laid the groundwork for our progression. These courses have endowed us with tools and insights that will undoubtedly prove indispensable as we immerse ourselves in the realm of robotics. So these are Introduction to Electrical Mechanical Systems and Automation, Pneumatics and Hydraulic Systems, Digital Principles, and Logic Designs. While the other essential course is purposive communication. In the context of our graded individual recitation assessment for this course, it's essential to recognize the significance of effective communication. So what are the mathematical tools that we will use in this course? So for coding, we will use VS Code for Python, a robust and versatile code editor. It will be our canvas as we paint our robotic creations with Python. Then MATLAB, this is a powerful mathematical software that will aid us in analyzing data, solving equations, and simulating various scenarios within our robotic endeavors. For proof of concepts, we will need drawing materials so that we can sketch and visualize our concepts before bringing them to life. Graphing papers offer a structured canvas to plot and analyze mathematical functions and designs. The Easy Robot Arm, a tangible tool. So this is the Easy Robot Arm. This will help us experiment with real-world robotic movements and interactions. And lastly, the ESP32 and Arduino Uno. These hardware platforms will serve as our playground for creating and testing physical robotic prototypes, adding a hands-on dimension to our learning experience. As we conclude this section, we've established a strong groundwork with essential tools and skills. From effective communication to valuable coding platforms, along with practical proof of concepts, we're now well prepared to venture further into the captivating realm of robotics. Be sure to join us in our upcoming lecture videos as we continue our exploration. Together, we'll delve into deeper concepts, unravel intriguing theories, and breathe life into robotic systems. Stay tuned and continue this exciting journey alongside us.